What we just did in chapter 7 with our factoring will come back in this chapter 8. Okay? What we are going to do in chapter 8. Chapter 8 is all about quadratic functions. Okay? A quadratic function is in the form ax squared plus bx plus c. Essentially, we're talking about a second degree polynomial. Okay, it has a name. Its name is quadratic. Okay. And what our focus is until our 3-day weekend is going to be graphing these quadratic functions. Okay? When we have a quadratic function, no matter what A, B, and C are, we are going to get what's called a parabola. Okay? Parabola. Okay, so today we're going to get familiar with what a parabola looks like and the properties of a parabola.
Wait, is that Miss Dixon's binder?
Uh-huh. Okay. A parabola. It doesn't look exactly like a U, but it's U-ish, okay? This right here, the turning point, do you see how it's going from like it decreases and then it increases where it turns? This is called the vertex. Just like an absolute value equation, it is symmetric. We can draw a vertical line through the vertex, and this is called our axis of symmetry. I'm trying to figure out where to write it. Okay, so every parabola is going to have a vertex. Every parabola is going to have an axis of symmetry. And those are two things that I will ask you to find. Okay. Now, we are going to start by just talking about what y equals x squared looks like. Okay. So if f of x equals x squared, what is 0 squared?
0.
0, 0. Okay, that's where our vertex is for y equals x squared. What is negative 1 squared? Do 1. What is 1 squared?
1.
Okay. So you see we have that symmetry. Okay. What's negative 2 squared?
4.
Okay. And what about 2 squared? 4. Okay. So there's that symmetry. Okay. In this parabola, the line x equals 0 is our axis of symmetry. Okay, maybe I'm going to do that in a different color. Okay. X equals 0 is our axis of symmetry because that's the vertical line that cuts it in half. Okay. Now, today we are going to focus on only the parabolas that have an A. So we're going to focus on parabolas that have an A, but not a B and a C. So this is what I'm going to do. I'm going to go to, where's my math? I'm going to go to Desmos. Okay. And I'm going to type in y equals a x squared. Oh, nobody told me the name. Hold on. No. Okay. So here's y equals x squared, ax squared. I want you to tell me what happens when I make a bigger. Ooh, it gets skinny. Okay. I'm going to go back to 1. What happens when I make it smaller than 1?
It gets bigger.
Oops. It gets fatter. Okay, now what happens when I make it negative?
It's going to go down.
It's upside down.
It's upside down. The bigger, thank you. Okay. The bigger the A, the skinnier it is. The smaller the A, the fatter it is. Positive means it opens up. Negative means it opens down. Isn't that fun? Okay. All right. So on the next page, go to 248. Okay. What we know is that if A is less than 1, then we know it's going to be, what I want you to do is I want you to say skinny. Okay? But if A is bigger than 1, oh, no, I got that backwards. They have it in the weird order. Okay, so this is going to be wider. Greater than 1 means it's going to be skinnier. Are you leaving me?
Yeah.
Okay, I have a worksheet for you. There you go.
Thank you.
Okay. When A is negative, means we're going to be upside down. Okay. So if A is less than 1, we're going to be wider. If A is greater than 1, we're going to be skinnier. And I made an absolute value because the negative is telling us whether it's opened up or opened down. Okay. If we take away the negative, is it going to be skinnier? Is it going to be wider? Okay. So on this graph right here, we need to be able to look at this graph and say, hey, what is the vertex? And what is the axis of symmetry? Is it okay if I abbreviate it? Okay. All right, so where would you say this parabola turns?
It would turn at 0, negative 2. Oh, that's the vertical.
Yep, negative 1, 1. Do you see how that's where it switches directions? Okay, so that's our vertex. Okay, once we know what our vertex is, we know our axis of symmetry is the vertical line that goes through it, which would be okay, don't just write negative 1. It is the equation of a line. X equals negative 1. Okay. All right, so go ahead and write down what you think the vertex and axis of symmetry is for number 2. I want to find my water. Jace, where's your vertex?
I got 3 and 4 positive.
3, 4?
Yep.
Do we agree? Okay. What's our axis of symmetry? Anybody? Did you get Emily?
3.
Half credit. X equals 3. It is a line. We got to write it as a line. Okay? All right. Now, let's talk about how I would want you to graph these. Okay? So, the first thing, when we look at number 3, I want to ask you, how does this compare to y equals x squared?
It's backwards. It says g of x.
That's okay. That's okay. It's just a different name. Okay? But since we have 5x squared, how is this going to compare to just normal x squared?
It has an exponent.
Is it skinnier? Is it wider? Is it the same? Is it upside down? Okay. We know that since this a is bigger than 1, it's going to be skinnier. Okay. Okay, so we're going to make an XY chart. And eventually, this will get simpler for us, okay? But for right now, I want you to plug in -2, -1, 0, 1, 2. Okay? And what we're doing is we're taking 5x squared and we're plugging in a number for x. So if we plug in -2, we have 5 times -2 squared.
So it'd be 10x squared. So it would just be 10 squared.
No. We got to do our exponents first. Do the exponents first. -2 squared is times 5 would give us 20. Okay. Now we're going to plug in -1. Remember, we do the exponent first. -1 squared gives us times 5. Okay. What's going to happen when we plug in 0? We're going to get 0. What's going to happen when we plug in 1? Oh, we're going to have some symmetry, aren't we? What about when we plug in 2? All right, so I'm going to put a V right here for vertex because 0, 0 is where we are switching directions, okay, in this graph. So I have 0, 0, 1, 2, 3, 4. I have 1, 5, and -1, 5. It doesn't look like I'm going to fit 220 on this graph. That's okay. We know that it's going to be super skinny. It's not a V. It's still U-ish. Okay, there's no point. It's still curved. Okay. We have our vertex at 0, 0, which means our axis of symmetry is x equals 0. Okay. Now here's something you haven't thought about in a while. Domain and range. Do you even remember what that means?
Domain, I think, is x.
Okay, domain is x. So where do we have x values?
0. Oh, wait, no, we have -2, -1.
We have x values everywhere. Okay? Any number we plug in is going to work. Okay? No matter what quadratic function you are working with, The domain will be all real numbers. The range is what's going to change. We only have y values where?
At the 1 and negative.
0 and up. We have a y value here, and they go up. So we're going to say our range, y is greater than or equal to 0.
So all real numbers basically goes infinite.
What'd you say?
All real numbers basically goes like infinite.
Uh-huh. Mhm. Okay. All right, tell me what we know about what number 4 is going to look like. It's going to be upside down, skinnier or wider? Okay, so a quick way to write upside down is reflected. Okay, and we know it's going to be skinnier. Okay, so now we're plugging into -4 times x squared. Remember, the exponents have to come first, then we multiply by the -4. So could you please take a moment while I take attendance, because I forgot to do that. Will you take a moment and fill this out for me? All right, -4 times -2 squared. What do we get? -16. -1 gets us -4, 0, and then we have symmetry here, right? Okay, we are always going to have symmetry around our vertex. Okay, now I'm going to make my x-axis way up here since it's going to go down. And I have a worksheet for you guys today, so like the graphs will be on there for you. That will help. Okay. We have 0, 0, 1, -4, negative. I'm not going to be able to fit the 16, am I? Okay.
So which numbers are we supposed to use? So like if it's going down, would we use the negative? Would we use the negative vertex? Like I'm saying, like which like x and y pairs do we pick to put on the graph?
So I'm telling you right now, just use these x numbers
Okay.
and then plug them in to get these y numbers and then put them on the graph if they fit. Okay. Now, we know our domain will always be all real numbers, but now that this one flips upside down, what's our range going to be? Y is less than or equal to 0. All right, how about you create number 5's graph for me? Well, I would say that A is -1.
Okay.
Would you agree?
Yeah.
Okay. If I ask you how this compares to the parent function y equals x squared, does it get skinnier or wider? No, it doesn't. It stays the same shape. But what does it do? It reflects. Okay, so we say that this one is reflected. Okay, but since A is technically 1, okay, the negative makes it reflect. The A is 1, so it stays the same shape as our parent function y equals x squared. Okay.
Where'd you get the negative 4s from?
Because if we take -2 squared, the 2 is being squared to get 4, and then the negative in front. Okay. Okay. All right, now I want to talk about number 7. Well, what do we know about number 7?
It's a slope.
No.
It's a fraction.
It's a fraction. That's okay. Fractions are our friends. So first of all, what does this negative mean?
It means it's going down.
Okay, so we know it's going to be reflected. A is 1/5. And if A is 1/5, what does that mean about the shape?
It's going to go down. Is it going to go down one and then right back?
What did you say, Dot? Huh? It's less than 1, which means it gets wider. Okay? So here's the shape of just x squared reflected. Here's the shape of x squared reflected and skinnier. Now we're going to have x squared reflected and it's going to be wider. Okay? So what's happening is we're taking -1/5 times x squared. So let's plug in 0. What happens when we plug in 0?
0.
Okay. So we know that our vertex right now is going to be 0. Okay. What happens when we plug in 1?
Would it just be 0.20? No, wait. 1 squared multiplied by -1/5 would be -0.2.
So I'm just keeping it as a fraction, -1/5. Okay. We know that 1 would be -1/5. And when we plug in -1, -1 squared times -1/5 is still going to be the same.
Oh, yeah.
Now, here's the deal. I don't really want to be graphing fractions. I don't love that. What would be a nice number to plug in?
Maybe we could say like 5.
Oh, would 5 and -5 be nice to plug in? Because what's 5 squared?
25.
Okay, so if we take 5 squared as 25 times -1/5.
So it would just be -5.
Yeah. And now I feel a whole lot better about making that side. -5 squared times -1/5. Well, that's going to get us the same thing. Okay, so I would suggest always plugging in -1, 0, 1. But if this is a fraction right here for A, it's totally cool to pick, instead of -2 and 2, maybe numbers that are just going to be a little nicer for you.
Maybe like squared.
Okay. What?
Maybe like squared. Because squares.
Well, we chose 5 because that coefficient was 1/5. If that coefficient was 1/3, I would maybe choose 3. Yeah. Okay. All right. I want you to read through 9 and 10. You have 3 options for your answer. Always, sometimes, never. I want you to talk about it with some human at your table and come to a conclusion on always, sometimes, or never for 9 and 10.
I could have come here telling it, but I didn't. Okay, human.
Your chair.
Okay, anyway. You got something fast? Alright, number 1. The graph of g x equals ax 2 is wider than the graph of fx equals x2 a dial 0.
With A, because you get back.
What?
Is narrower the exact same as skinnier?
Yep.
Greater than. So you just call them left and right. Remember that. Is that true? Or sometimes, never, always.
It's never, sometimes, always.
Thanks for helping.
So we know it could be always. We know it could be sometimes. We know it could be never. So that leaves us 3 options.
Is AX2
That's a
wider?
33%
Look,
chance.
is AX2 wider than X2
Is what?
when A equals, or when A is equal to 0?
What are you saying? Oh, you're talking about this first.
What do you think I'm talking about?
All right. I would like to take it to a vote. Number 9. Always. Sometimes. Never. Okay, we're going to vote again. Always. Sometimes. Never. Nobody was right. To be fair, we only... Okay. When A is greater than 0, okay, is 4 greater than 0?
Yeah.
And what's true about if A is 4?
That means it's greater than 1.
Then it's narrower. Now, is 1/2 greater than 0?
Yeah.
Yeah. And if that's true, then that would be wider. But 4, which is greater than 0, would make it skinnier. So this is only sometimes. All right, number 10, always. Sometimes. Never. For the people who actually voted, you are correct. It is never. Because this would make it wider.